right, we'll start talking about multiplicity, but it's best to talk about multiplicity after you graph, and then we show you visually what it is I'm describing so that you have a visual for what it is you're doing, okay? So, we're going to graph this polynomial. All right, now, you have zeros. Okay, so let's write on here so I can write really big. All right, zero product property, x is equal to what here? Positive 5. What is it here? Negative 2 and negative 5. Yes? All right, look up, pay attention. Okay, now you need to go from smallest negative to most positive, right? Because this kind of represents the x-axis, right? So leave it open. Negative 5, negative 2, positive 5, right? I have an extra one here that you guys don't have to use, okay? Yes? Okay, if these are my zeros, x-intercept solutions, what is the y value here? On all three of these, what are the three y values?
0.
0, very good. Right, so graphically, you have negative 5, 0, negative 2, 0, wait, let me make sure I don't mess up, and 5, 0. Okay, so right now you have this function. You just have to figure out what is it doing. Like, is it starting from the bottom and going up? Is it starting from the top, looping, bouncing off, running through? Like, you guys now need to get the visual. So, not bad at all. What's the number to the left of negative 5? Negative 6. And remember, when we plug this in, if the number is really large or really negative or really positive, we can go negative 5.5 or negative 5.2. We can pick a number that's a little closer to our little grid. Okay. All right, so if I substitute negative 6, I get negative 6 minus 5 squared. Do not forget about that exponent. Negative 6 plus 2, negative 6 plus 5 squared. So you type exactly the function. It's just you replace negative 6 for x, 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 right? Okay, so what do I get? All right, this is a huge number. Like huge, right? Okay, if it's a very negative number, if you guys don't like that, and maybe you're like, well, let me go negative 5.2. You can pick any decimal. You don't have to go integer. There's negative 13. So if I wanted to choose negative 5.2, I get negative 13. Right? Okay, so if I come to my graph, negative 13, if this is negative 8, negative 13 is about right, you could kind of fidget, but it's looking like this, right? So it's going to come up, right? I'll go after with marker. Okay, between negative 5 and negative 2, so this is negative 5 and this is negative 2, and this is negative 3, negative 4, what's my half number? Negative what? Someone said it. 3.5. So now take negative 3.5, and if you don't clear your screen, you just, can you see? Yeah. You just substitute and get your output value. And I get negative 243. So this is huge. Okay, so either way, it is coming way down here, right? So we'll just put it down below. It's coming down, and now it's got to go right back to negative 2, right? guys quiz or test, the numbers aren't this large, okay? We just want to get you guys comfortable with very big positive or very negative large numbers, okay? Now, between -2 and 5, what is, so this is -1, 0, 1, 2, 3, 4. Okay, what's the middle number? So if I go 1, 2, 3 in, 1, 2, 3 in, I'm at the half, and it's what Brandon said, 1.5. Yeah? Okay, so take 1.5 positive 1.5 1.5 1.5 and I get huge. Okay, I get 1,018.11. Okay, what's the point of it though? At 1.5, it's basically way up here, and now you're coming right back down. So this is 1.51811, right? So because you guys are not in calculus, your polynomial functions, they're kind of estimations as in terms of your max, your local max, local min. They're never going to be precise because you guys don't have the calculus, okay? And so then you just now substitute, what's a number 6? We already know it's going to be huge, right? Okay, so if I substitute a 6, right, then you're going to get a large number, and that's your graph. And when you guys test, we don't give you these large numbers. Like, it's something that fits. Maybe we'll go into the 30s, but we won't give you hundreds. Did I do that right? 6 minus 5, 6 plus 2, 6 plus 5. Okay. And you get 968. And so here is, we're back up here. So what is it? 968. And you're bouncing off and coming back. Okay, this is the part we kind of want to focus on. So, all right, you guys see how this is a square and a square? See how this is an even exponent? Yeah? Okay, this is what multiplicity, this is what this kind of talks about. Multiplicity means if that root 5, that's where it came from, 5, has an even exponent, you get a parabola bounce off the x-intercept, or the 0, the solution. So see here, this was -5. See how you got that quadratic bounce off. But if it's, what's another color? We'll go green. Okay. But if it's odd, see how this is odd because it's the number 1? Granted, you don't see it, but you should. I'll go over it with pen. It's a run through. It runs through the intercept. This says odd. Even. Okay, so if you guys had, this is kind of like now SATs then. If you guys were given this and they asked you, okay, from the 5, from A, B, C, D, which graph matches it? If you understand 1, 2, 3, 4, 5, right? You're here. You're at -2, -2, 5, -5. Here. Okay, your only thing is you need to find out what -6 is. You have to plug in -6. Okay, why? Because I just need a starting point. After that, I can easily graph it. Obviously, I'm not going to have exact points, but I just need a starting point. So if I plug in -6, I get -11 squared is a positive number, right? -6 plus 2 is a negative number, so that's a negative. And -6 plus 5 is a negative number, -1. Squared gives me a positive number. And what's a positive, a negative, and a positive? A negative. So now, once I know that negative 6 is somewhere down here, I now know how to graph it using multiplicity. Because this negative 5 is off of, because this negative 5 is off of that even, I know that I'm bouncing off. I'm coming right back to the negative 2. The negative 2 has an odd multiplicity because it's a 1. I run through it, I come back to the 5, it's squared, I bounce off, and I run through. That's what multiplicity does. It allows you to understand whether it's squared, if it's even, odd, or even. You shouldn't have an idea of how the graph should behave at your intercepts, at your zeros, at your solutions, right? Those are synonyms. You just need a starting point. And then you should be able to just get an idea of how the graph should look like. You just use the table to get these exact values. Not that they really matter, because we're not like actually representing a function here, but this is what it is, okay? All right, I totally forgot I was recording. I kept going and going, I forgot. Oh, let's do end behavior. Sorry, end behavior here. Just because I'm talking anyways. All right, when x approaches positive infinity, what is y doing? So as x moves more and more to the right, what's this function doing? What do I get? As x gets more positive, what's happening to the function with the y-axis? Yeah, positive infinity. Someone said it over there. All right, as x approaches negative infinity, what is y approaching? So as x becomes more negative, the function is doing what? Which is? Negative. Right. Yeah? There's your end behavior. Okay, I'll stop it.